the probability that two friends share the same birth month is. So you have two friends, and first person, this is the birth month of the first person, this is the birth month of the second person. Now, this person can take 12 different values, right? This particular person can take 12 different values starting from January, right? From January to December. We have 12 months in total. So this particular place can be filled in 12 different ways. And again, this particular place can also be filled in 12 different ways. This particular person can also have a birth month starting from January, ending in December. So we have actually 144 different combinations possible. 144 different combinations of birthdays possible. What I mean is that first person, let this person be A, and if this person is B, A can have a birthday, a birth month as January. Then we can have January or February or whatever it be up to December, which means that with January as A's birth month, we can have 12 different options. So A can have 12 such options. So 12 into 12 is 144. Now, out of this 144, I need to find the number of favorable outcomes, which means that both these persons must have the same birth month. So January is one such option. Both having February as birth month is next option. March is another option, which means that I'll be having 12 different options. So my probability will be 12 divided by 144, which is 1 by 12, right? This is 1 by 12. So the answer must be 1 by 12. Now, maybe you'll be having a confusion when you directly go for probability. You will take that this particular person has a birth month with the probability of 1 by 12, and the second person also must have the same birth month. So for that, the probability is 1 by 12. There, the problem is that this is the probability for both having same birth month as either January or February or December or July, whatever it be. Both these people have the same birth month, and you are restricting that birth month. You are not allowing them to take all the 12 different options that they can have. This is the probability that both these persons have the same have July as their same birth month. Then the probability is 1 by 12 into 1 by 12. But when you ask for, when the question is to find the probability that two friends share the same birth month, you are not restricting the month. You can have all months starting from January to December, which means that for the probability to be for the probability that both these friends have the same birth month as January, that is 1 by 12 into 1 by 12. So I have 12 such options, which means that the answer must be 1 by 12. Also, you can think it in a different manner. The first position, I have two positions. I am not bothered about this position. This position can take any of the values from 12 different values. But when I go for this thing, I have to make sure that this thing is same as this one. So if this is March, this must be March. If this is February, this must be February. So the probability is 1 by 12 then. So my answer is 1 by 12. You can find out the answer in different manners, different methods, that's all. Consider two events, E1 and E2, such that P of E1 is half, P of E2 is 1 by 3, P of E1 intersection E2 is 1 by 5. Now, question is, which of the following statements is true? So, first option is P of E1 union E2 is 2 by 3. So, P of E1 union E2 is P of E1 plus P of E2 minus P of E1 intersection E2. So, P of E1 plus P of E2 minus P of E intersection E2 is something which you can directly find because you are given all the values which you require to find P of E1 union E2. So, P of E1 is half, E2 is 1 by 3 and E1 intersection E2 is 1 by 5, which means that union will be 1 by 2. The probability of union of E1 and E2 will be 1 by 2 plus 1 by 3 minus 1 by 5 because P of E1 intersection E2 is 1 by 5. So this is 5 by 6 minus 1 by 5, which is nothing but, I'll write it here, which is nothing but 25 minus 6 divided by 30, which is 19 divided by, right, 25 minus 6, it's 19 divided by 30. So this is wrong. It's not 2 by 3, it is 19 divided by 30. Now, E1 and E2 are not independent. E1 and E2 are independent. So one of these two things must be the answer, because both these things cannot be simultaneously false, which means that one of these things must be true. So actually I'm not supposed to find, I need not find this particular value, but still we'll go to we'll find this value too. So E1 and E2 are not, when two events are independent, I can say that if P of A intersection B is product of probabilities of each events, which is P of A into P of E, then they are independent. So if E1 and E2 were independent, P of E1 intersection E2 will be product of these two things, which means that it must be 1 by 6. But here it is 1 by 5. So they are not independent, they are dependent. So this, see, E1 and E2 are not independent. This is the right answer. Whereas E1 and E2 are independent. This cannot be right, because you must be taking the product of these two things to get intersection value, probability of intersection E1 and E2. But in this case it is 1 by 5 and not 1 by 6. So they are not independent. If you want to find P of E1 given E2, we know that it is P of E1 intersection E2 divided by P of E2. P of E2 is 1 by 3 and P of E1 intersection E2 is 1 by 5, which means that it will be 3 by 5, but it is given as 4 by 5, so the answer must be 3 by 5. So this is also wrong. So this is wrong, this is wrong, and this is wrong. These two are not independent. E1 and E2 are events in a probability space satisfying the following constraints. P of E1 is equal to P of E2. Now P of E1 union E2 is 1, which means that these two events, they are the only two events. The meaning of P of E1 union E2 is 1 means at least one of these things must happen, which means that these two constitute the entire sample space, right? These two are the only events that is present there in that probability space. Now, though that is not required for you to solve this problem, I was just mentioning the meaning of what it means by P of E1 union E2 is 1. Now, E1 and E2 are independent. Then P of E1 is. So you have to, the given condition is that they are independent. When two events are independent, you know that P of E1 intersection E2, right? P of E1 intersection E2 is product of individual probabilities, P of E1 and P of E2. This is what you mean by independence. When two events are independent, their intersection value is nothing but the product of individual probabilities. So in this case, P of E1 is P of E2. So we need to find P of E1. So P of E1, let us take it as X, right? Now that is P of E2. Now, since that it is given that they are independent, I know that P of E1 intersection E2 is P of E1 into P of E2. Now, it is also given that P of E1 union E2 is 1. P of E1 union E2 is nothing but P of E1, right, plus P of E2 minus P of E1 intersection E2. P of E1 intersection E2. Now, P of E1 I have taken as X. P of E2 is also X because they are same. P of E1 and P of E2 are same. Minus P of E1 intersection E2 is product of P of E1 and P of E2, which must be X square here because this is X, this is X. So X minus X, 2X minus X square must be 1, which means that if I take the entire thing to right side, I can write X square minus 2X, right? X plus X is 2X, I take it to the side. Plus 1 is equal to 0. X minus 1 the whole square is equal to 0, right? So X is 1. Value of X is 1. The solution for this quadratic equation is 1. So what it means is that this probability must be 1. P of E1 must be 1. So P of E2 will also be 1. So what it means is that in the entire sample space, these two events, both these things are equally likely. Both these things definitely will happen because the probability is 1. So E1, P of E1, P of E2, both these things are 1. And thus, what we have to find P of E1. So the answer is 1. A box contains 10 screws, 3 of which are defective. Now, 2 are drawn at random with replacement. The probability that none of the 2 screws is defective will be. So, you have a box with 10 screws, 3 of which are defective, which means that 3 will be defective, 7 will be non-defective, right? Now, the question is, you take 2 at random with replacement, which means that first you pick a particular screw and you see whether it is defective or not, then you place it back to the box, then again you pick it, right? That is what you mean by picking it with replacement. Now, the question is the probability that none of the 2 screws is defective will be. So both these screws must be non-defective. So I have 7 non-defective ones out of total 10 screws. It means that when I go for the first pick, my probability, the probability of getting a non-defective one in the first picking will be 7 by 10. Now, there is no reduction in the number of screws present in the box because I am replacing it. I am keeping it back to the box. So in the second case also, my probability of picking a screw which is non-defective will be 7 by 10. Which means that in the first picking it will be 7 by 10 and in the second picking also it will be 7 by 10. And now I know that these two are independent events because regardless of what I have got in the first picking, I will be getting in the second picking. It means that when I want to find the intersection of these two events, or rather I want to find the condition that this happens and this happens, right? In the first picking I must get a non-defective one, and in the second picking also I must get a non-defective one, which means that my probability will be 7 by 10 into 7 by 10, which is 49 by 100, which means that my answer must be 49%. The hydraulic events has 4 gates which operate independently. The probability of failure of each gate is 0.2. Given that gate 1 has failed, the probability that both gates 2 and 3 will fail is. So, when you read this question, maybe you will feel that this is a conditional probability question. But actually in the first sentence itself, it is given that the 4 gates operate independently, right? Which means that this has nothing to do with this has nothing to do with this has nothing to do with this, right? So these events operate independently, which means that if the question is to find the probability that both gates 2 and 3 will fail is, so they are independent events. This has to fail if this is 1, this is 2, this is 3 and this is 4. This has to fail and this has to fail. So reading the question itself, we can say that if I have to make sure that 2 has to fail and they are independent. So if 2 intersection 3, when I write 2, it means that gate 2 has to fail. When I write 3, it means that 3 has to fail. This is the notation that I am using. So when these two are independent, I know that it is P of 2 into P of 3, right? When independent, when I want to find the probability of simultaneous occurrence of independent events, I know that I have to take the product of individual probabilities. So the answer must be 0.2 into 0.2, which is 0.040. You know that. But in case if you have a confusion with why they have given a conditional probability kind of statement, like given that gate 1 has failed, so we will see whether we get the same answer when we go through conditional probability. P of A given B is P of A intersection B divided by P of B. Here B is the condition given, which is gate 1 has failed. So in the denominator I have to write the probability of, right, I have to find the probability of gate 1 failing, 0.2. Now the numerator I have to find the probability that gate 1 has failed, gate 1 has failed, and along with that the question is to find the probability that both gates 2 and 3 will fail given that gate 1 has failed. Gate 1 has failed, which is B, and A is the event that both 2 and 3 will fail, which means that A intersection B means I have to make sure that gate 2 and 3 will fail along with, right, that is A intersection B. This is P of A, right, this is P of A. P of A is the event that 2 and 3 will fail. P of B is the given condition, which means that 1 has failed. So A intersection B means both these things must happen simultaneously, the given condition and the required condition. The given condition is that 1 has failed. The required condition is that 2 and 3 must fail. So 2 and 3 will fail, and along with that 1 will fail. It means that I'll be getting the same answer. So there is no problem with that. Since that it is a case of independent events, there is no need for you to find the conditional probability. That's why we went directly to find the answer as 0.040. But in case if you have a confusion that why they have given a conditional probability kind of a statement, you can very well go in this manner, and again you will be getting the same answer.